Hello and welcome to the next evidence briefing from Lincolnshire Research School, and this time we're looking at improving primary science and the guidance report linked to that. So my name's Alan Ethorn and I'll be working with you in this video, and my colleague Karen, and we will both be working through this video with you. Just things to note. We've recorded this as a video, so obviously use it as you wish, pause it when you need to, and fast forward and rewind and all of those kind of things. Hopefully that helps for you to use it for yourself and possibly with colleagues as well back in school. So just a quick reminder about what we do. So as a research school and the EF, these are the sorts of things that we're doing. So this video falls into the category of the mobilisation. So it's about sharing and getting out the information that that we have and the evidence, and getting it into schools for you guys to use in schools. And a reminder, I think always really helpfully, I like this slide, that this is that thing. I think often we talk about evidence-informed practice, and it's that reminder that that's made up of evidence and the use of our professional expertise as well. And it helps teachers and leaders to make more informed decisions about what to do and also what to stop doing as well. And to kind of think about the kind of best bets when we come to these things. So the video today is focused particularly on science, and hopefully we'll share that link between what the evidence is suggesting, match that with our own professional expertise, and allow us to be evidence informed. If you have signed up, then you don't need to do this, but if you're watching this video or you're using this video in other ways, then please do use the QR code. That will take you through to a short questionnaire survey, just to help us to understand our reach and to kind of to gather some data on engagement and where we are with that, and to help us for the rest of the series as well. So the Improving Science Guidance Report has recently been released. Hopefully you have seen it. I suggest that whilst you're watching the video, maybe pause it now, and to find on the EF website the guidance report and have that alongside you. If you're using this as a leader with colleagues in a staff meeting, things like that, then make sure everyone can access the guidance report as well. Lots of the slides will refer to pages and parts of the guidance report, but obviously on the screen it's not so easy for you to see all the details. So do watch this video alongside having the documentation there as well. So just very quickly to share where this has come from. So for over the last kind of 2 years, a group of colleagues have been working on this guidance report, and the idea of mobilizing that evidence that's out there, rather than each individual one of us working through the 15,000 studies and the 90 most robust and relevant ones, that the EF has done that hard lifting for us, and those group of colleagues have done that, which is great. And then so the information that you'll find in the guidance reports are the kind of the key findings from doing all that heavy lifting. So that's why we always say these guidance reports are a really great place to start in these circumstances, and to help, in this case, improving primary science. So in this video, Karen and I are going to work through the 6 recommendations that appear in this guidance report, and those that you can see on the screen, those are the 6 areas. We'll go into a little bit of detail about each area, but as we said, if you've got the guidance report as well, that'll help you to kind of go into particular areas of, if there's a particular area that you want to read more about or find out more, then obviously, you'll be able to, to get to that point. And to use the video to help you with that as well. And then I shall pass over to Karen.
Thank you. So the main aim of this was science is just very complicated, and we just wanted to pull out the points that it's all about scientific knowledge and concepts across all the subjects, but it's also about the nature, the processes, the methods, the skills, and then how to apply that, and that the implications of science in the wider world, which we'll be discussing throughout this report. But the key thing is just to try and spark that joy, that curiosity, to motivate our pupils to want to learn and find out more. So we're going to go through this. Now, and I were speaking before about the recommendation, and each recommendation is almost a whole day or more days of training. And so we will just looking at the headlines, and we will also signpost you to other resources. And as Alan said, give you time to stop and pause and really discuss this in your staff meetings. So the first one is developing pupils' knowledge of specific vocabulary, identifying that and teaching those new words and meanings over time. Why it's important, like I say, I'll give you time to read this when you pause the video, but it's really important so that children can actually access the curriculum. Without this knowledge, they really can't talk about science, access it, and understand it. And that then leads through for their whole education from primary into secondary. Each of our recommendations have a vignette. We're going to send this as an additional tool. They're really interesting discussion points for you to use in your meetings. So we've added them here as well. A good point for you to pause the video, look at it, ask the questions, discuss, and then continue. So the very first recommendation, 1A, is to identify that vocabulary. And you would have probably heard lots about tier 2 and tier 3 words, and it's been really clear of which ones you want. You'll be looking at particularly between 5 and 10 words, depending on your key stage. And the joke here, I like this, and like good joke, the force is strong with this one, and it certainly is. And that word can be used in so many different contexts. So it's just understanding that and how that links in different vocabulary. So once you've chosen those tier 3 words and those tier 2 words, and that takes quite a lot of time, you need to think about how to map that out. And here's just one example of how that's been done. And that's a continuation of that. So you've spent the time choosing that vocabulary, mapping that vocabulary out. And then when you've got those words, it's how to explicitly teach the new words with their meaning. So you'll need to be modeling that, creating a content for words that need to be learned, using that in, like we said, in different literacy activities across, not just in science. And then promoting that discussion, that use of the words. The children are revisiting it as much as possible. For a child to remember a word, it has to be revisited at least 10 to 15 times. So thinking about how you're going to do that. I've added a lot of slides here for you to just come back and look at how we've done that, and ways of just teaching that word with a dictionary definition that the children can understand, and then getting the children to discuss that word in context. This can be done through PowerPoints, and pictures helped. It could be done through embodied cognition. There's lots of evidence behind that with the word to help the children remember that. And dual coding. Sometimes the creation of flashcards can be really helpful with that embodied cognition. Like I said, we'll give you a chance to look at these words. And then those deepening activities, for example, making word choices and what does that word link to, and also word association and matching exercises. And all of this links very closely to the Key Stage 1 and 2 literacy guidance report. So it's worthwhile having a look at that as well. I'm just going to signpost you to the Freya model. It's really useful when teaching sciences and in all other subjects, and this could support your teaching of vocabulary. Also, just to signpost you to the lightness system, there's lots of YouTube videos about this. This is a really good way of children to learn to self-test and to revisit that vocabulary independently. We've also included on every recommendation lots and lots of blogs, and particularly with the vocabulary, there's a lot of blogs out there for you to look at. And Alan has also made a nice document which we'll share with you, so you can click on all of these blogs later.
Great, thank you, Karen. Yes, so So as we know in lots of our work that we're doing in our curriculum in primary, that obviously vocabulary is really important, and that explicit teaching of vocabulary and I think, Karen, that kind of being clear of where it all kind of builds to, and that progression, and identifying particular vocabulary to use at the right point, and those things. I know that's something that we've done with our curriculum, and it's really important. Otherwise, it kind of gets lost, or children can't explain.
And I think this is one of the things that takes the most time, isn't it? And making sure that whoever's doing this, the lead in science, has got that time to really map that out and think about how it's going to look.
Absolutely. And it leads really nicely into the second recommendation, which you can see there, which is about, having got that vocabulary and that language and those things, to then using that to help children, and allowing opportunities for children to think explicitly about, to think about those concepts and what they're coming across in science, explicitly, whether it verbally or in written form as well. So I'm just going to go through that bit briefly. And again, like Karen said, if there's any points you want to pause, then obviously do so, and have the guidance report there as you're going through. So we know that oracy is really important. We haven't got time to go into all of the details of that now, but we know that oracy is really important, and we know that oracy isn't just about having a chat about stuff. That there's that kind of really careful, planned opportunities that allow pupils potentially to recall or organise, express their thoughts and ideas. And science is a wonderful subject to allow those things to happen. All those kind of, when children first notice those kind of awe and wonder things of how does that work, and why is that, and what is that force that I can feel, and all of those kind of things, and just how important then the oracy element of that is in that, and those opportunities within those lessons, and the experiences that we can give the children. So if you want to pause, so this is a vignette that you can find in the guidance report. So if you want to pause the video there. And again, these are really useful. We're not going to go through all of these, but in the follow-ups, but they're really useful to start those discussions. Often, if you're using this as a science leader in a staff meeting, and one of these vignettes might be a really nice way of starting. So the first area looks at the first area this recommendation looks at, as it says there, create a collaborative learning environment. And we know, and this isn't specific particularly just to science, but we know just how important this is, about having that environment that allows for that kind of collaboration. And science is a great subject to be able to do those things, whether it's taking a concept and trying to kind of think through and getting people's ideas, or whether it potentially is those practical elements and conducting experiments as well. And those three areas there about taught behaviours, expectation setting, and task design, you'll see more information in the guidance report with that, and we'll talk a bit more about that in a second. The second one, as we've mentioned, talks about that idea of dialogue, and thinking about and as a teacher how to support that high quality dialogue that we know is really important. And again, and like I said, how key that is. So whether that's planning key questions and discussion points. I know in our curriculum in science we have those questions kind of ready to go. We know obviously teachers, you need to be adaptive as well, but we have some key questions there to help and to have those real kind of hinge points, I guess, in lessons about, and then also about that kind of thinking about ways of guiding dialogue, and we'll talk a bit more about that in a second. And also that those opportunities for pupils to share their thoughts and ideas, and not just to be in a lecture, as it were, from the teacher kind of going through all of these things and these ideas. And then you can see quite naturally how that forms into that those opportunities then for pupils to kind of cultivate their reasoning and their justifications. And that's a really nice model there that kind of can set out that and can help those things in terms of taking that kind of explanations and sort of adding more to it and refining what they think and their kind of and how they explain those things. And then, if you've been teaching as long as I have, you'll have come across concept cartoons that were, I don't know, quite trendy probably 15 years ago, and everybody did them in every lesson. And then, like lots of good things, we just stopped doing and potentially, and sometimes we forget. But what a great tool they are for developing oracy, that kind of structure, not inhibiting those conversations, but allow for teach children to kind of have that kind of structure, along with things like sentence stems as well, to help pupils to think and to share their thoughts in that way. And as Karen said, we'll share these links on a document as well, so you can see how some of our research schools have been focusing on these areas. Karen, back to you.
Thank you. So our next recommendation, and all of them seem to actually link to their own guidance report, links to the metacognition and self-regulation guidance report. So it's really useful to be having a look at these alongside this. And so in the first two recommendations links very much, as we already mentioned, to the literacy guidance reports. So hand in hand, we're giving you a lot of information here. So what this one is looking at, if I can just move it, because I can't quite see the top. Jumping back, is how to explicitly teach the knowledge and the skills required to work scientifically, and how we're going to guide the pupil to apply this to the practice. Now, there's a lot of information in science, and it's how to help our children remember that information, how it can make sense to them, and how then they can use that to apply it in discussion and reflection. So this is how it's shown in the science guidance report, but you will notice, I'll let you read that later. I'm jumping ahead a little bit to the vignette here. I'll let you pause. How it links directly to the metacognition and self-regulation 7-step model. And what's really nice is how it goes through that then in detail in the report. So it's that moving from the teacher leading to moving to more independent learning there. And in the it looks to that I do, we do, you do. So if you know about the walkthrough, that direct link there. And it's how important it is to start by activating that prior knowledge, which could then link to the concept cartoons. That could be a way of doing that. It could link to diagnostics, but that discussion to see where those children are. And then it's really important, that explicit strategy of instruction. This could be linked to that vocab teaching. Really, but then it could be used to link to other areas. And as we know, that moving on to that modeling with the teacher, really showing that through demonstrating how it looks. And that memorization is really key, because without that, and that's that revisiting, that retrieval, the children won't have that knowledge there to be able to move to that guided practice, and then ideally that independent and that structured reflection. So it's really useful linking that model to the metacognition booklet. And it's just high quality teaching, really. We were talking about this before, weren't we, Alan, in all teaching. So again, take time to have a look at this. One of the really nice tools that they've sent, and we'll share with you, is an example, a worked example for year two lesson on light and prediction that will show that. And we've also developed our own booklets, which we will help you, but it's also looking at those misconceptions as well that might come up. And through those oracy in recommendation 2, that will help you sometimes identify those misconceptions. So it really all links up. And is there anything you want to add before I move on?
Just going to say, I think you mentioned about that guide. It's that how you as a teacher guiding through that process. I think the misconceptions there are really important. That I know sometimes there's that kind of, oh, we must do this as a teacher. You need to do all of it in one lesson, and absolutely not going to be able to do that. And that's why quite often, I know years ago, things that children used to be really bad at writing conclusions, because usually it was the last thing that they would have done in the lesson, and so then they'd run out of time, and it was like just any old thing. And so I think that's really helpful to kind of help think about what particular bit that we need to do, how we're going to model it, and absolutely, like you say, ultimately it's about working scientifically, and that being as important as the vocabulary and the knowledge. It's the how does scientists work, which actually is not too dissimilar to how teachers work, is it? In terms of identifying a problem, trying to solve it, and and that kind of process, evaluating it, and those sorts of things.
Yeah, and as Alan said, it often that in step gets missed out, doesn't it? We just sort of almost run out of time. So it's really making sure that we're doing that, and that really careful modelling. Now, I know I missed out some bits, so just remember that you can pause here on the vignettes. I was so excited by the 7-step model that I jumped ahead. So it's really important to have a look at these. They're really useful starting points, as Alan said. And also you'll have time to have a look at these a little bit later, and just pause these videos. So these are really, really useful tools. There's a lot to talk about here, and to take time to research further. So what we're doing is really just signposting you, but I would highly recommend that guidance report as well, and using these tools, which we will send to you. And again, here's lots of useful blogs and recommendations to look at. And as I said, we have actually made our own booklet to help you with this, with lots of examples about how that looks. And so you can really think about those steps clearly and make sure that they are there in your teaching, and maybe think about which is the area in your school you might need to focus on more. Is there a bit that maybe gets missed out when we're doing this? And often we talk about, when I've done this work with other teachers, it is that reflection part, and sometimes it's that memorization part, and what sort of work you might need to do in that as a staff to develop those areas.
Thanks, Karen. So moving on to the fourth recommendation, and again builds on what we've talked about so far. So this one is about helping children to relate the learning to relevant and real world context. So trying to make sure that that children don't see science as just something you do on a Monday afternoon between 2 and 3, or that kind of thing. That science is happening all the time, and thinking about those things, and seeing it as things that happen in the world around us, as it were. So, as I said, it's fairly obvious why it's important for those real world contexts. It brings it alive. It makes science a living subject, something that's happening all the time that they can see as where they are around them, and kind of can allow children to relate. And often that thing of it kind of links to the geography about if you go for local area walks when children are younger, and that just noticing stuff, just getting their head up and actually noticing, oh, why is that, and why does that, those sorts of things. Why is there moss on that side of the roof and not the other side of the roof, and that kind of thing. And so there's the vignette for this one. So again, if you want to pause at this point. And I think, just without going into too much detail, the second question there about how can I create learning opportunities that are memorable for the right reasons. We've all taught those science lessons where it's been a catastrophe, and everything's kind of got fallen to pieces, and all sorts of different things when 30 children are all doing an experiment at the same time. So it's that thing about that kind of planning for those things, thinking about those things. Is this the right is this going to be memorable for the right reasons, I guess, and hopefully. And to sort of to help with that these kind of, again, in the guidance report, you'll see this is quite a useful way of kind of working through it, in the sense of going back to that planning of what is it that I want the children to know and to understand. This context that we're going to provide, whether how does that support it, and that could be the activity, it could be the experiment, it could be the field work, as it were. So what, does this context actually support it, and how does it do that? And then I think really what I find quite interesting is the potential challenges with that context, and the chance of misunderstanding. So we did a kind of action research, some work a couple of years ago, in our school, looking at science experiment, and how do we teach that. And one of the things that we came to, which we weren't expecting to, was just how actually, if you haven't taught something explicitly, as in some knowledge, if the children are gathering that knowledge by doing an experiment, and it possibly goes wrong, given that the children doing a science experiment in a classroom with not particularly scientific measurements or apparatus and all of those kind of things, is there a chance that actually they go away from that lesson getting the complete wrong idea just because their experiment went awry and they didn't realize that? So I think that's kind of really important about how do we bring that back to make sure that everyone does know those things, and therefore making sure that those experiences actually help, as opposed to kind of maybe hindering. And obviously, as well, thinking about how we can draw upon kind of virtual models and all of those things. And I won't go into lots of detail about that, but we know just how, nowadays we have much more opportunity to be able to share those kind of virtual models and to help those really difficult concepts. So whilst acting out, the solar system and things with various people going around in circles and stuff is good, it might be useful to use the virtual model as well, that might help kind of to explain those things and to demonstrate those things more easily. And then just finally, there's again some useful sort of questions and thoughts there about that, linking those experiences. And there's a blog there as well about making those real world connections as well. Karen, back to you. Was there anything from that I missed there?
No, I think you covered that very well.
Have you had those experiment afternoons where it's not quite gone to plan?
No, I'm just reflecting on yes, classfuls of children and equipment all over and measurements, but they certainly, yeah, they always enjoy it.
Yeah.
So now we're looking at responsive teaching. Alan and I were discussing this before. This is again linking to the feedbacks, guidance report, all forms of assessment, diagnostics. It's a complicated one in itself. So we're just going to look at the headlines again, and we'll go through them in a little bit more detail. But as you can see, really good teacher assessment can have very high impact, but it's how to do it well and thinking about when to do it and using that assessment well, formative and summative. So that's looking just at the headlines. I'll just let you read why it's important. So of course we want to use assessment to identify knowledge and appearance, but so we can be responsive in our teaching, so we know what those next steps are, and really so we can identify misconcepts as well and have a really good understanding. It's not just about summative testing at the end of that. It's about being responsive. And again, we'll just give you a chance to have a look at this. And this is a good point to pause the video and just to discuss this as a starting point. Just looking at some interesting questions there. And really things like this is always that big question, how can I effectively assess what pupils have learned when working scientifically? And you say there's a lot happening in that classroom, and how do we know who's really understanding that, who's using the processes and the method? I don't think you've got anything to add for this one, Alan.
I think just like you say, it's that those two link quite nicely, don't they? It's that kind of what am I hoping to get out of it, and making sure that you build in those opportunities so that you as a teacher can capture, if a child says, oh, what have you learned today? Or the red car's faster than the blue car. It's like, oh, no, that wasn't the point, that wasn't the point of the lesson. It was about forces or air resistance or something. I think, like you say, it's that kind of, if you're clear about what what you want the children to learn during the lesson or series of lessons, then how do you capture whether that's actually happened? Which, yeah, not.
Yeah, and I'm just looking at the vignette. It's really useful. The idea of mini whiteboards is a really nice way to start or end a lesson. It's just to see any misconceptions, but it's also a great way of retrieval as well, and that all part of that memorization process that we're trying to work towards.
Yeah, yeah.
So really, I'm just going to look at the headlines here. So 5A was just looking at how you can plan teaching that builds on existing knowledge and experiences. So it's that prior knowledge, but where we're going to next. And the headlines here are just really recognizing what you want to access, revealing that understanding how you're going to do that. And there's lots of sort of ideas then, like we've just talked about mini whiteboards, different types of diagnostics, quizzes. And then when you've got that, how you're going to respond to that in your planning, particularly when there's misconceptions there. So 5B is just looking at monitoring pupils' learning to inform, like we've just said, really responsive teaching, feedback, and next steps. And it's all about that, really. And some nice headlines here. So, how to clarify and share the understanding and those learning intentions and success criteria, being really clear what that learning is at the very beginning so you know where you're going to. But what is that evidence of learning? If they're just busy doing an experiment, what learning is going on? You know, if they're having those conversations, how are you going to really find that out? And then how are you going to reflect on that and adjust your teaching? And as Alan said, often there's a lot of happening, isn't there, in those experiments? And this is just quite an interesting model that you can look at in more detail when you're looking at the guidance report. But it's looking at the bottom, you've got your active pupils, they're very busy, and then maybe they're doing self and they're doing a peer assessment. And in itself, that needs teaching how that looks and how's that done. And you're watching that and you're listening to those conversations and you're getting your diagnostics and those mini whiteboards, but then you're responding to that. Really careful questioning, which can also link to recommendation too and feedback. And if they've been taught explicitly that vocabulary, you should be starting to hear that in those discussions to check they have that understanding of those words. And again, it's all linked in. That's a way of revisiting that vocabulary, making the links, checking that shared understanding is there. And then you can move on to maybe towards the end with that summative reporting and just you might do a mini test at the end to see where they are. And that'll feed into whole school processes, linking back to that planning that we've talked about, that planning out of your vocabulary, what you're studying next, where that needs, and maybe there's some weaknesses that you need to do a little bit more work on. Maybe is the understanding scientifically, or there's some knowledge that's more difficult for children to understand. What we're going to do about that, how you're going to put that into your planning so it makes more sense. And is there anything you want to add from this?
No, no, I think no. There's, I think some of that point comes up in the next. Next,
Perfect. I will move on.
perfect.
Here's a nice example of that, which you can pause and have a look at. And I just added this summary because I think it's also very nice. It should be seen as assessment is a tool viewed as for improving teaching and learning rather than just simply measuring outcomes. And sometimes I think in the past assessment was seen as how we're going to measure outcomes rather than responding to the needs of the students. And again, you can discuss that as you look at that vignette. And there's a few useful blogs. You'll see that what the research schools are very interested in writing blogs on the vocabulary, particularly in the 7-step model. The blogs become less and less as we go through. Alan, over to you.
Great, thank you. So the final bit, which is probably about a year's worth of training in itself, but so having gone through that kind of whole process, that you know, this as a leader potentially of science in your school or schools, it's then thinking about, as Karen mentioned, you know, as primary teachers, we teach lots of different subjects. So you know, from that point of view, supporting colleagues to become, you know, to become really effective teachers through professional development is I guess, well, it's complex, isn't it? And so for this bit, as Karen mentioned, all of those sort of recommendations prior to this help you to also to kind of, you know, understand where teachers are in terms of, you know, vocabulary. Are they secure? Do they feel okay with that? working scientifically? Have they ever had any training on working scientifically, or is this, from sort of tacit memory of being in secondary school and learning science at school, that type of thing? So again, we won't go into lots of detail about this, but to kind of think about that then as a leader, about what, where particularly are we going with this, and what can we do? So if that's, oops, moved on. So we know how important professional development is and high quality teaching. And if you need to pause just to read that, then that's fine.
I think I would link that as well with that implementation, as we know they go hand in hand. And again, that's like a whole other year of training.
Yeah, absolutely. And I think on there, really importantly, it's that, that sustained senior leadership buy-in as well. So, all the things that we've covered in this are multiple, over time. So, how are you going to build this into kind of a year or a 2-year plan, in amongst all the other subjects that potentially are in the same process? So there's the vignette. So I'll let you pause if you want, or use the guidance report to come to that. And then just sort of to go into a little bit of detail about the areas. So the first part of this recommendation says, so to use a range of information to identify development priorities and professional learning needs. So as Karen mentioned earlier, it's that kind of, the kind of, I don't know, deep dive or the learning walks, those sorts of things might be as useful as assessments, and those, book looks and all of that help feed into that as a science leader. What aspect of science teaching a teacher's really finding most difficult? Talking to the children, are they able to explain, as Karen mentioned in the first recommendation, are they using the vocabulary? Do they know the vocabulary for this unit? Is there a plan for, all of those things? So as always in this process, it's that kind of information finding in the first instance, and just how important that might be from multiple sources. And then with that in mind, to line that up against those kind of key features. So thinking about making sure that professional development is about building knowledge and helping teachers to build their knowledge. Often in things like science, it can be their own subject knowledge as well. About obviously it's professional development and the power of that has to motivate staff and empower teachers, and to build confidence and all of those kind of things. The importance of professional development in developing teaching techniques, as it were. So, how do you model a scientific explanation? How do you kind of use peer support? How might feedback be used in that process? Linking into coaching and things like that potentially. And then also, as we know with professional development, how do you get that then to be embedded in their practice, in teachers' practice in the classrooms, so that it's not just a one-off, here's a staff meeting on how to run a science investigation in the classroom, right, off you go and do it. That's going to be really difficult. And so thinking about how we're going to monitor that, what we're going to do, how we're going to support people, which comes back to that point of having that buy-in from senior leaders and making sure that, it's given the priority. And then, as I've mentioned, then that kind of, that feeds into the idea of thinking, that's, from that strategic point of view of how are we going to do this? How are we going to make sure it's in place? What are we doing? How's it all feeding together? Are all the cogs kind of turning and we going in the right direction with all of those things? So thinking along those lines. And in the guidance report, there's a really useful document that can kind of help you to think through the areas that we've discussed today, and to then use that as a sort of starting point, maybe to think, well, which one of those recommendations is it worth us focusing on first, rather than the temptation to try and do all of it, which particular area. And that will only come from that kind of collecting those, that evidence in the first place. And there's a blog as well. Was there anything else there, Karen? CPD and professional development is a massive area, and there's more information on the EF guidance report about that specifically.
I think, as you said, it's that time taken to explore and really find out what it is you need to be focused on in your school, because you can't do it all. So it's what part, doing fewer things better, as we always say. Evaluate your staff. It's confident bands. So maybe what you think, which areas do they feel least confident, where do they want that professional development, finding out their beliefs and values, really. So just take that time.
Sound advice. Absolutely. And at this point of the year, it might be those quick wins before the summer, but it might be building towards doing activities over the next couple of terms that build into that. Okay, and this is what we're going to do from September. This is how we're going to support staff from there.
But like we said, these recommendations are high quality teaching and can link to all areas of your curriculum. So maybe if you want to focus on that, you could see how it looks across the whole school.
Absolutely. So hopefully there's been plenty of new learning there for you. It'd be really helpful, for you, obviously, taking notes, those key reflections, what the bits have you kind of gathered from this. And I think what's great and why we changed to kind of providing this as a video is that you can go back and replay the particular areas, and it might be that you only, when you're focusing on one particular area, just watch that part of the video, and that allows you that flexibility. And also it allows you to then reflect maybe in a bigger group, or with colleagues about kind of the next steps. What are your next steps in this process? What are you going to do? What kind of resonated most highly, and potentially the first bit is about gathering that information to know what kind of is next. So that's to say thank you. I hope this video you found that useful. The video is there forever, so as it were, so you can go back to it and use it whenever and however you want to. And hopefully that's given you a very brief summary of some quite complex and highly detailed areas to focus on. Karen, was there anything else you wanted to say before we finish?
Just really, it's signposting. So if you choose your area, hopefully the blogs will be able to support you. If you ever need more help in an area, just please write to us and we will give you more information on that. As we said, most of the recommendations are linked to a guidance report. And yeah, and just thank you for engaging with this.
And then just to remind you that these are a series of videos. So we've already published a video on the pupil premium strategy, implementation. This is science. Next time out, we're looking at effective professional development, SEND, and then metacognition and self-regulation. So you will get these. If you've already signed up, you'll get these. If you haven't signed up, do go to the Lincolnshire Research School website and sign up, and you'll get these sent directly to you when they are released.
So we just finished that. That's the end of that. And that's just to say thank you very much. And we look forward to seeing you on our next evidence briefing.